Hello, my name is John Lambert. I'm here at APEC to talk to you about the new products being released from International Rectifier using GaN technology. They're the first in industry to be released to market. The high-level concept for the products is that we're integrating a driver and a GaN-based switch into a substrate-based packaging technology. Everything is flipped. There's no wires inside. This allows us to switch at high frequency with low parasitics. We don't have a lot of additional noise. So here we have a block diagram showing you what the device is comprised of. We've got the power inputs and outputs here on the right shown. On the left we have the IOs. As you can see, we have a driver IC and a monolithic GaN switch. So we have Q1 and Q2 integrated into a single chip. All of this makes it for a low parasitic, high-fast switching device. So we've got the IP2010, that's a 30 amp device capable of switching up to 3 megahertz. We have the IP2011, it'll be a 20 amp device capable of switching up to 5 megahertz. These power stages are compatible with industry standard TTO logic type controllers. It could be used for single phase or multi-phase applications, digital or analog control.
I know.
Here we've got some efficiency comparison. This is showing the IP2010 compared to the best Dr. Moss devices in the market. We have peak efficiencies of 93%. At full load, we have at least 4.5% compared to the nearest competitor. To competitor B, we actually have closer to 7% in efficiency. This is at 600 kilohertz switching. I also have an example here of the devices, the IP2011 and IP2010 switching at 1.2 kilohertz. As you can see, we have better than 90% efficiency peak with both devices. And this is at 12 EN with a 1.2 volt output. Here we have examples of some demo boards that are configured for two-phase operation. I have a schematic here showing you what these two-phase schematics look like. So we have the IP2010 shown here, being controlled with an IR3623 controller. And here I have a slide that I can give you some comparisons on the footprint space savings capability that the GaN devices could give designers. So we have a discrete application shown operating at 400 kilohertz. This shows the magnetics and capacitance required for that kind of an application. We also have a Dr. Moss example showing the space required for 400 kilohertz operation. And then we have an example of what you can do by doubling the switching frequency to 800 kilohertz. And you can save 35% footprints compared to a Dr. Moss solution, or up to 40% if you compare to a discrete solution. Okay?
Thank you.